In Lesson 5.3, we're going to consider two ways of solving a system of linear equations algebraically. Now, we've already talked about how to solve a system graphically. So one way is by substitution, and there are 5 steps listed here for the process that's involved, where we solve one equation for one of the unknowns, substitute that solution into the other equation, and then solve that resulting equation. Then you should have the final answer there. And then that is an ordered pair or a point, and you would check those values in both the original equations. The second method is by addition or subtraction. And we're going to go through the steps in this one as well. We need to get the equations in an appropriate form. And then once we do that, we want to eliminate one of the two variables. And we may need to multiply all terms of an equation by a constant in order to do that. Once we solve the resulting linear equation of the other unknown, substitute this value into the original to find the value of the other unknown. So, and then we're going to check the solutions or the values in both the original equations. So to begin with, let's look at solving a system substitution method. So this is our two equations, equation 1 and 2 that we have. And when we use the substitution method, what we'd like to do is solve for one unknown. So in this case, equation 1, x has already been solved for. So we're going to take 2y plus 1, since that is another name for x, and substitute it into the second equation. So we end up with 2 times 2y plus 1 minus 3y equals 4. And then we just simplify this to solve for y, combine like terms, and we find out our solution for y is 2. Now, once we find out that y is 2, we can replace y with 2 in either one of those two equations. Okay, so I'm going to replace y with 2 in the first equation. And when I do that, I end up with x equals 2 times 2 plus 1. So our answer for x is 5. So that means the solution is going to be the ordered pair 5, 2. And you can also see this graphically if we were to graph the two lines. Now, to solve a system of equations with the addition method, what we would like to do is line up our two equations. We have to make sure they're in ax plus by equals c form. And once we do that and we have the same number for the coefficients but different signs, we just add. So we're going to take these two equations, and when we add them together, adding the x's, we get 3x, adding the y's, that eliminates the y, and then 7 plus 2 is 9. And then to solve for x, that's 3. Once you get an answer for x, you can substitute that into either one of the two equations to find the solution for y. So we're going to substitute that answer into the second equation, and our answer for y ends up being -1. So the solution for this system is 3, -1. Also graphically, that's the point where the two lines intersect at 3, -1. Now, sometimes the equations are not quite that simple. Here in this case, we've got two equations in the form ax plus by equals c. But if we were to add those, we would not be able to eliminate one of those variables. So we have to take care of that. So the way we're going to do that is we need to decide which one we want to eliminate. In this case, what I'd like to do is get rid of the x's. So that means I need the x coefficients to be the same. Well, in the first equation, I'd have to multiply by 5, and the second equation, I'd have to multiply by 3. And that way, my x coefficients are going to be 15. Okay, so as you notice, when we multiply by 5, we've got to be careful that we multiply the entire equation by 5, each term. And the same thing with the second one. We've got to multiply each term by 5. Now we've got these two, so we can subtract them. If I take 15x and subtract 15x, then I'm eliminating the x's. Negative 20y minus a negative 18y is like saying plus 18y. That's going to give me negative 2y, and 35 subtract 3 is 32. Dividing through by negative 2, my answer for y is negative 16. And just like with the other problems, I'm going to substitute that negative 16 for y in either one of the two equations to figure out what x is. So I chose to use the first equation, replacing y with negative 16. We find out that x is negative 19. So our solution is negative 19, negative 16. That's the point at which the two lines intersect.